Okay, this is lesson 6.6, example 2. And again, we're going to try to model a trig function. So this one's about a Ferris wheel. A Ferris wheel has a radius of 25 meters, and its center is 26 meters above the ground. It rotates once every 50 seconds, and suppose the rider gets on the ride at the bottom at t equals 0. So we need to take this question and pull out as much information as we can. So here we go. First bit of information is the radius of 25 meters. That should tell you something about the function and about the graph. When you have a radius of 25 meters, radius is a direct relationship to the amplitude. So it's giving you the amplitude of your ride, because the radius is from the center to the max or the center to the min, and that's exactly what the definition of amplitude is. So we have the amplitude as 25 meters. And its center is 26 meters above the ground. That's telling you about the center of the graph. And the center of the graph is your axis. And your axis is your c value. It rotates once every 50 seconds. How long it takes to make one complete rotation or one complete cycle, that's your period. So that's telling you information about the scale of your graph. The scale of your graph will be in seconds, and it will take 50 of those seconds to make one complete rotation, which is, if we're talking about sine, from rest through max, back through rest, through min, and then back to a resting position at the axis. If it's a cosine function, it's from max to min to max. But in this situation, the rider gets on at the bottom. So that means we have a minimum at t equals 0. So we're starting from the bottom of the graph. So let's try to put all these pieces together and come up with a sketch, and we'll use that sketch to come up with our graph. And we want our sketch in the first 2 minutes. 2 minutes is 120 seconds. So it wants 2 periods, which is 100 seconds, plus another 20 seconds. So we want to go a little bit past 2 periods. The question would have been better if it was just 2 periods or 100 seconds, but we'll work with it and we'll approximate the rest of the graph here. So here's my scale. We're going to go up by 50s and 100s so we can kind of use the period to sketch our graph here, and then we'll continue it a little bit to get our 120. What do we know? Well, we know the axis is 126, so that's going to split through the middle of the graph. Not 126, 26. And using y's, maybe not using y's. What could we use instead? Well, this question's about heights, so we should probably use height. So let's go with the height equals 26. Axis, or your amplitude, sorry, tells you how much from your axis to your max and how much to your min. So we're going up 25 to get to a max, which means down 25 to get to a min. And down 25 from 26 is 1. So our graph is actually going to start at the bottom at 1. And we know one full cycle is going to put us back down to the bottom here at 50. So where's the maximum going to be? Well, the maximum is going to be right here in the middle at 25. So that's your max. What would your max be? Min's 1. 6 is your axis, and up another 25 would put you at your max, which is 51. We know we're going to be at our axis value in between 0 and 25, and in between 25 and 50. So we get a little bit of shape to our graph here, and we know it's going to be curved, so we want to try to curve it as best possible. So it's going to look something like this for one cycle. And then for our second cycle, we know it's 75 in the middle. It's going to go back to a max. Split the difference to hit your axis, and we can complete the picture. And that'll give you one full cycle. And we know after 25, it's going to be back up to rest, so we're not going to get quite there to get to 120, so we'll leave our graph right there to complete our first 2 minutes. So there's our sketch. Amplitude's on there from your axis to your max and your axis to your min. Your period is shown because we're doing one cycle in 50 seconds. Our second cycle completes after 100 seconds. And then a little bit more to get you to the 120 seconds. Find the equation. To find the equation, you need a few pieces of information. You need, well, let's model our equation. We're going to talk about heights and times in seconds. So our function is going to be h of t. And it's going to be a times sine or cos, we'll come to that part in a second, of k, and then t minus d plus c. So we need information about a, k, c, and d, and we need to figure out whether it's sine or cos. We've picked out a few of these pieces already. We've picked out amplitude, the radius, and we've picked out c. So we know those two pieces. A is 25, and c is 26. If they're not given to you, you can find A by doing max minus min divided by 2. And in this case, that'd be 51 minus 1 over 2, which is 25. And if you want C, you can find C by doing max plus min divided by 2. And that would be 51 plus 1 over 2, which is 52 divided by 2, which is 26. So you can actually find them from the max and min, but they are given to us in the question, so we don't have to do that work if they're given to you. So we got A and we got C. We can plug those into our equations. To find K, we need to use our little mini equation. K is 2 pi over the period. We know the period's 50 seconds, so K is 2 pi over 50. And if we reduce that, we get a K of pi over 25. Now we've got A, C, and K. The last piece we need is D. D comes from when you're choosing your model. So we know our graph is starting at a minimum. Neither sine or cosine start at a minimum. So we need to use a transformation of sine or cosine. Since cosine starts at the maximum, if we were to vertically reflect that graph, we would start at a minimum. So to model this, you want to pick either sine or cos, whichever is closest to the graph that you sketch. And by closest, I mean whichever one moves or shifts the least left and right. And since you're just reflecting from max to get a min, you're not actually shifting the function at all. And by shifting, I mean you're not changing the d value at all because there's no horizontal shift. So the best model is the one that reduces your d. And the smallest d was 0, and we can get there by just reflecting. So if we use negative cos theta as our parent function, we know to do that because at t equals 0, the height is at a minimum. And when you use negative cos, your height is at a minimum. So if we use negative cos as our parent function, d would be 0 because we wouldn't have to shift left or right. And now you can complete your graph or your equation. H of t equals negative cos, so negative 25, cos, we've got a k of pi over 25, t, no d, plus 26. And there's the equation of our function. So, long story short, how do you come up with an equation from a description? You pick out all the necessary pieces, try to translate them to a, k, c's, and d's, try to pick a model for your function, in this case cosine, or negative cos because we're starting from a minimum. Sketching usually helps you come up with the characteristics. If you're not asked to sketch, you don't have to sketch. And then the model for your equation is always a, in this case, cos, because we use cos, times cos, k times t minus d plus c. Pick out a, k, c, and d, and then plug them into your equation to come up with your final answer. Try example 3 on your own. Check the solutions on the course website, and we can confirm tomorrow in class. Thanks for watching.